So students, today it is our second session about unit 2, that is of enzyme, and today we will see the second section of enzyme action. It covers with four major points: active sites, mechanism of enzyme actions, factors that affects enzyme activity, and how enzyme activity can be inhibited or stopped, or you can, in another word, you can say regulated. Okay? Active site of enzyme. Active site means what? As the substrate molecule are comparatively more smaller than the enzyme molecule. There should be some specific region or site on which enzyme will bind with substrate. Means so કે substrate ને bind થવા માટે એન્ઝાઇમ ઉપર એક એક્ટિવ સાઇટ અથવા એક પર્ટિક્યુલર રીજન હોય છે જેને આપણે એક્ટિવ સાઇટ કહીએ છીએ, કેટાલાઇટિક સાઇટ બી કહેવાય અને સબસ્ટ્રેટ સાઇટ બી કહેવાય. અને સાઇટ્સ છે મીન્સ ઇટ ઇઝ નોટ નેસેસરી કે એન્ઝાઇમની પાસે એક જ હોય, એક કરતા વધુ સાઇટ્સ હોય, પણ એ બધી સ્પેસિફિક હોય સબસ્ટ્રેટ માટે. બધી સાઇટ ઉપર બધા સબસ્ટ્રેટ બાઇન્ડ ના થાય, એને સ્પેસિફિકેશન કહેવાય એનું. Now properties of active sites. The active site occupies a relatively small part or portion of enzyme molecules. First thing, the active site is neither a point or linear or even a plane, but it is dimensional region or entity. It is made up of group of components or part of amino acids. For example, lysozymes have a 6 subsites in a active sites. Usually, this arrangement of atoms in the active site is well defined. Once you can understand it is well defined region. After knowing the dimensions and 3D figure, you can easily recognize this is an active site. The active sites binds the substrate's molecule by relatively weak bonds. Normally, it is bounded but with a weak bonds. The active sites in the enzyme molecule have a grooves or cleavages, from where the water is largely excluded. There is a very few less amount of water, so bounding can be perfectly created till the complex substrate converts into product. It contains amino acids such as aspartic acid, glutamic acid, lysine, serine, etc. And this side chain, it contains a side chains of carboxyl group, adenyl group, ammonia group. Now, mechanism of enzyme activity or enzyme action. What is the exact mechanism of enzyme action? There are many formulas has been developed, many type of models have been developed, but the well understood and well accepted model was developed in 1898 by Mill Fisher. Fisher, he proposed a model like a lock and key. As we know, there is always specific key and lock. દરેક તાળાની એક સ્પેસિફિક કી હોય, એના ગ્રુવ્સમાં એ ફિટ થાય તો જ ખુલે અથવા બંધ થાય. Same way, Fisher's this lock and key model indicate same way that you can see this, that substrate, it binds with this substrate binds with enzyme comfortably, and then only it can be converted into a product. The active site has a rigid shape. According to Fisher's model, Emily Fisher's model, it is like that active site is always rigid, and when it gets a perfect match of substrate, it can go for enzyme substrate complex. In fact, this enzyme substrate depends on the reciprocal of the feet between the molecular structures of the enzyme and substrate. એટલે કે બંનેનું જો સ્ટ્રક્ચર જે છે રેસિપ્રોક થાય તો જ એ ચાવીથી ટાણું ખુલશે. This enzyme substrate complex is highly unstable and also immediately this complex decomposes to the product to produce an end product in the reaction, and again regeneration of free enzyme can be occur. So what I understand that by Fisher's model, lock and key model, આપણને શું ખબર પડે છે કે enzyme અને substrate બહુ rigid હોય છે, specific shape ના હોય. જો એ બંને બાઇન્ડ થાય તરત જ એનું પ્રોડક્ટમાં કન્વર્ઝન થશે અને ફરીથી ફ્રી એન્ઝાઇમ અવેલેબલ બનશે. This has some limitations to understand, which was recovered by the modification of this lock and key model, which is known as induced fit model. In this, there was a major change was that active site is flexible and not rigid. The shape of the enzyme, active sites, and substrate adjust at maximum way in a maximum way that it fits and improves the catalase activity. There are the great range of substrate specification. The model is more consistent and wide range of enzymes has been occupied by this model has accepted. In this, you can see કે એની એક્ટિવ સાઇટ જે છે ઇન્ડ્યુસ ફીટમાં એનો શેપ થોડો અલગ હોય છે. જ્યારે સબસ્ટ્રેટ સાથેના કોન્ટેક્ટમાં આવે છે ત્યારે એ અકોર્ડિંગ ટુ સબસ્ટ્રેટ ઇટ લિટલ ચેન્જ ઇટ્સ શેપ, એટલે એમાં શેપમાં થોડું મોડિફિકેશન થાય છે. This induced fit model was developed by Koshland. He presumed that the enzyme molecule does not retain their original shape and structure while it comes in contact with substrate, and configurational or geometrical changes જોવા મળે કે જેથી એ totally fit થાય અને it takes some more tight fittings once the enzyme substrate complex એક specific range માં વ્યવસ્થિત બની જાય એ પછી જ એમાંથી પ્રોડક્ટમાં કન્વર્ઝન થાય છે. As the sequence of event, when we want to summarize these things, sequence of events during the conformation changes are three possibilities. ત્રણ પ્રકારના changes ત્યાં જોવા મળે. First, the enzyme may first undergoes a conformational changes that helps in binding the substrate. Alternative pathway is that the substrate may be first be bounded and then conformational changes may occur. Vice versa, ક્યાં તો એન્ઝાઇમમાં conformational changes થતા હોય કે જેથી કરીને સબસ્ટ્રેટ સાથે ફિટ થાય અથવા સબસ્ટ્રેટમાં થતા હોય. Both the process may be simultaneously occur. એવું બી બની શકે કે આ બંને પ્રોસેસ સાથે થાય with a further isomerization to the final conformations. Coastline model was now gain much experimental support, and we believe that this induced fit model is more authentic in compared to lock and key model, and various enzymes were used to demonstrate this practical, like keratin kinase, carboxyl peptidase, etc. After this understanding of action, first of all, the thing which should come in mind is that activation energy. What is the need of energy that is needed for an action that is provided by enzyme? All the chemical reaction requires some amount of energy to start the reactions. For example, if we want to start our scooter, we go for giving kick or indicator થી આપણે એક સ્ટાર્ટઅપ આપીએ છીએ. પછી ગાડી સ્મૂથ ચાલે છે, પણ એકવાર એને શું જોઈતું હોય છે? સ્ટાર્ટિંગ. અને સ્ટાર્ટઅપ માટે તમે કિક મારો છો, તમે ક્લચ સ્વિચ થી આપો છો, કે whatever you are using, it is a one type of energy which you are providing to start the reactions. In this graph, you can very well understood the thing which I want to say. Activation energy means in this you can see there is one reaction without any energy. Means uncatalyzed reaction, it takes a long time to become active, and then it can convert into product. Well, when you use some energy from enzyme, this activation energy time duration will be reduced and easily you can convert into product. It is important to remember that enzymes do not change during the reactions. In another words, there is a no change either in a reaction is exergonic or androgonic. This is because they do not change the reactant or product free energy. They only reduce the activation energy required for the transition state. એન્ઝાઇમ પ્રોડક્ટની ક્વોલિટી કે ક્વોન્ટિટીમાં કોઈ ચેન્જ નથી કરતું પણ એ જે ટાઈમ ડ્યુરેશન લાગે છે કે આ પ્રક્રિયાને વેગ આપવા માટે જે જરૂરી એનર્જી છે એ પ્રોવાઈડ કરે છે. Okay. Another point is factors affecting the enzyme activity. Enzyme action કેવી હોય, active site શું છે, and એનર્જી એક્ટિવેશન એનર્જી શું કહેવાય જોઈએ. હવે કયા કયા ફેક્ટર્સ છે કે જે એન્ઝાઇમ એક્ટિવિટીને ઇફેક્ટ કરી શકે, that we will see. Okay.